Hello, fellow students. My name is Timothy Brown and my partner is Hannah Furness. We are comparing porosity and permeability under different soil management systems. Introduction. This experiment was conducted with the intent to differentiate the management effects on the soil porosity and the permeability in four distinct different soils. Porosity is the reference to the amount of pores or open spaces between soil particles, and the reference to how much resistance soil water has as it passes through the soil between the spaces is permeability.
The objective of the experiment was to separately test four distinct management zones. As a team, Tim and I used the exact same testing procedures to record the variation and then analyze the data to conclude how managing soils differently affects its ability to function.
The study sites we used was turf from Hannah's yard, and then the soil from underneath an old pool that had been removed, and then a traditional corn and soy no-till field here in Trade County, Kentucky, and a hay pasture not too far from that same location.
In our methodology, in order to measure porosity, we first filled a cup up to 100 milliliters of water and measured the exact same amount of soil. We then slowly poured the water onto the soil until the soil became completely saturated. Then we stopped pouring. The leftover water of the 100 milliliters we had was then measured to see how much water was being taken in by the 100 milliliters of soil.
Permeability. We used the same cup and the same amount of soil with 100 milliliters of water. As I started to pour the water onto the soil, when the first drop hit the soil, I started a stopwatch. I continued to pour until that water completely permeated all the way through and dropped. A single drop came out of the bottom of the cup. We stopped the timer.
In our results, we found that the overall porosity was highest in the no-till corn soybean rotation field, followed by turf grass, the hay field, and the least porosity was under an old soil pool, which probably had to do with compaction and a lack of organic matter.
Permeability. The best permeability was in the corn and soybean field, no-till, and very close followed by the hay field, then the turf grass, and then a very slow permeability rate was recorded in the site where the old pool was.
In our conclusion, we found that management practices and soil texture play significant roles in the overall outcome and permeability. With the increase of soil amendments and light disturbance events, the permeability rate increased. However, the opposite effect is seen in soils with more human intervention and traffic. The same can be applied to porosity. The exception to this pattern is the hayfield. This supports the idea that the light occasional tillage may have recorded quantifiable permeability benefits. Managing for porosity is affected in high traffic soils that experience low to no organic matter and biological activity, as in the situation where an old swimming pool covered the soil.
This concludes our presentation. Thank you very much.